So for today's opener, and then a little bit into today's class, we worked with angles a bit, and this is going to summarize some of what we found. So this right here is an angle made of a line segment and a ray connecting at this vertex right here. To name it, bless you, we could potentially have a labeled point on either side and a labeled vertex. So that's right, this one's labeled FUN. So when two rays or line segments share an endpoint, if I can clear that away a little bit, they form an angle. So a lot of times you talk about the angles inside polygons, and those are made of line segments. The ones in your journal you looked at today are all formed with rays, where they would, in theory, go on forever. The vertex, and the plural of vertex is vertices. The vertex of an angle is the endpoint where the two sides meet. And then we have a couple of options when we're naming the angles. You don't want to write the word angles. Angles can be labeled with a symbol that looks similar to a less than sign and just its vertex, unless there's more line segments or rays that come off of it, then you have to be more specific and use a point from each side and its vertex in the middle. So the angle above could be called angle FUN. It could be angle NUF, or in this case it could just be angle U, because there are no other line segments or rays that come off of it. Now we're going to go into, that's all about what an angle is and the labeling of the angles, but the next segment is about classifying angles. So the first one that we're going to look at is a right angle. A right angle would measure up to the corner of a piece of paper, exactly. So how many degrees does a right angle have? Yes, sir. 90 degrees. So to classify an angle, you don't need the precise amount of degrees. You just have to be able to compare it, usually, to a corner of a piece of paper. The next one we're going to look at is an acute angle. So a lot of times people go, oh, it's so teeny tiny and acute, like puppies or kittens. So that's like a mind trick to remember, like what the acute one is, tiny little thing. So it's going to measure greater than a certain amount and less than a certain amount. Who thinks they know what the blanks are going to be for that? What do you think?
0 degrees and 90 degrees.
Greater than 0 degrees, it has to actually be an angle, but it has to be smaller than 90 degrees. So again, if you compare it to a corner of a piece of paper, you're going to be able to see that it's less than that corner. The next one is an obtuse angle. So if someone is medically obese, then they're big. So obtuse and obese, a lot of times people use a memory trick to remember that. So an obtuse angle is going to measure greater than such and such. But then we also have to specify it's less than a certain amount as well. When I was a kid, we just said, oh, it's just bigger than such and such. But there's actually a maximum it could be. So what do you think should be our two numbers in here?
90 and 180.
Greater than 90 degrees, but less than 180 degrees. Because if it's 180 degrees, it's going to be a straight angle, which is what we're having next. A straight angle measures 180 degrees. And again, all I need is a piece of paper because I can just compare it to one of the straight edges of my piece of paper. So whenever I'm trying to classify an angle, I don't have to take out a protractor. I can just compare it either to the corner or the straight edge of a piece of paper. Does anyone remember what it's called if you have an angle that's beyond that? We actually had that in today's opener as trying to, bring it back to memory.
A reflex angle.
A reflex angle, and I could never remember this, so I was thinking, oh, when you're at the doctor's office and you get a reflex and it kind of swings around. I mean, it doesn't swing that far around, but the reflex of your knees and your elbows and kind of elbows around. So a reflex angle, who thinks they can help fill in the blanks? Measures greater than what, but less than what? His name. Greater than 180 degrees, but less than 360 degrees, and the degree symbols are all in there. So those are our angle classification. The next thing we need to do is jot down a few notes about angle relationships when you have angles forming straight lines and such. So everybody's got that so far? Clear the ink? Moving it down. So when two lines intersect, angles next to each other are called adjacent angles. And because they were formed from a line that got intersected, they add up to 180 degrees. And then down here, in general, angles that create a straight angle are called supplementary angles. Straight, supplementary, some people use that trick. Some people use the S to be turned into an 8, like 180.
What do you call an angle that's 360 degrees?
Nothing. Back down to nothing. Right? It's just a line segment then, or a ray. For filling in the rest of these notes, we do need to label this diagram. So I put a P here, the point in the middle is our P, and then I put a Q and an R up here, and I put an S and a T down here. So, if I'm trying to find things that are next to each other, I kind of just work my way around the diagram. The first one I did was the measure of angle QPS, so that's this one here, Q to the P to the S, is going to get added to the measure of angle Q to the P to the R, and would get me 180 degrees. So that's looking at this one here with this one here. Now if I work my way around, next one I'm going to look at is this one that I just left off with its neighbor over here. So the measure of angle QPR, if I add it to its neighbor, the measure of angle RPT, they'll add up to 180 degrees. But the next one I'm going to start where I just left off, the angle RPT with its neighbor, SPT or TPS. So the way we phrase it could vary a bit. The measure of angle RPT added with the measure of angle SPT. They're going to create a straight line, it would be 180 degrees. And then the last pairing I'll do in blue, just to finish off this thing that looks like it could be the flag of a country. This and its neighbor there. I have the measure of angle SPT or TPS. Remember, we could flip the order and it would still be the same thing. Plus the one I left off with, or started off with rather, QPS. Measure of angle QPS. Add up to 180 degrees. So the big picture is, I had a diagram like this, and they asked me to find all the angles. I would only have to measure one. And then I could do the computations to figure out the other ones. Because if I measure this one, then I go, oh, what does it take to get this one to be 180, and what does it take to get that one to be 180? That's the same one computation. But then this one has to be whatever this would take plus what to get 180, so it's going to be congruent. So the ones across from each other end up being congruent because they share a supplemental angle. So let's see, what color are we on? Let's go with this one. Angles that are across from each other, opposite angles. Again, that's the term that makes most sense to me. They're opposite to each other. Or vertical angles. Don't know the origins of that. Doesn't make as much sense to me, so I just have to remember it. Are congruent. So in the diagram we have up there, it means angle QPS is equal to angle, let's see, QPS is over here, so it's equal to RPT. Angle RPT are congruent. The measure of angle QPS is equal to the measure of angle RPT, but the angles themselves they call congruent because they have different points on them and such. The next one is the other angle QPR. That's the top here. and it is congruent to angle at the bottom SPT. So you have to look for relationships